Hello, and welcome to the Voice of Mobile Apps. Let me come over here. Thank you for coming. Opening the room up a little bit to let people come on in early so we can try to hit the ground running at the top of the hour. My name is Bradley Metrock, CEO of Project Voice. I just learned something interesting about Zoom. I had the wrong date and time for this webinar in Zoom, and when I tried to load it, it said the thing is expired. I'm like, oh no. I had no, and some nightmare fuel. I just changed it in Zoom and all of a sudden it works. So kudos to them for having figured that out, and I'm going to monitor email and make sure we don't have anybody pinging us who wasn't able to get in. So thank you for being here. As we have seen, voice, conversational AI, and mobile apps all have a robust and growing intersection. We've seen it. We've seen it over and over again. Really, we were seeing it before the pandemic started, and there were some interesting implementations. And now, amidst the pandemic, there's, like so many other things, there's been some really interesting developments. And you're going to hear three great companies today talk about their perspective on it and some of the things that they're working on. I'm going to go ahead, while people are still queuing on in here, Alex from Voicify, I'm going to go ahead and promote you to panelist, so we can be ready to go in just a second. Alex, how are you?
Doing great. Can you hear me all right? Oh, we got the wrong camera going. Hold on. Let me switch cameras here. There we go. Hey.
There you go. Thank you for joining us.
Yeah, no problem. Excited to kick things off here.
Yeah, so I'm going to, we're getting started. We're doing this a little bit differently. We're starting right at the top of the hour. So people are going to be queuing on in, but I'm going to go ahead and make you host. Awesome. And while I do that, I will say two things. If you have questions that come up during the talk, please put them in the Q&A box. And also, if you are registered for the event, you're going to get the audio, you're going to get the video after it's over. So if you miss something, you come and go. We know how these work. Don't worry about it. Alex, thank you and Voicify for being here and kicking us off.
Awesome. Let me share my screen so we can kick things off here. All right, how's that looking?
Yeah, looks great. Perfect.
Ready to roll? Cool. So I'm excited to talk to you all about optimizing voice experiences in mobile apps. A little bit about me, if I can get my clicker to work here real quick. I'm Alex Dunn. I'm the Chief Product Officer at Voicify. You'll find me online mostly as Suave Pirate. Basically, my name is super ordinary, and I found it really hard to find myself and sort of make a presence on the internet when I was first getting started in my career. So I used a name generator I wrote when I was about 10. And so it's been Suave Pirate ever since. You can get my Twitter, LinkedIn, my email there. I also stream on Twitch, building some stuff around mobile and voice, which is super cool. And I also basically focus mostly on application development, AI, and accessibility. At Voicify, we basically try to focus on making it as easy as possible to build and manage these cross-platform voice experiences, from Alexa skills and Google Actions and Bixby capsules, all the way to custom embedded voice assistants. And especially lately, what we've seen a lot of growth in is voice assistants right in our customers' mobile apps. So today we're going to be talking about optimizing those experiences and focusing that on a couple key areas. We're going to be talking about the modalities, and especially the differences between what we see in sort of the voice only interfaces, or like the voice first interfaces in mobile. We'll talk about making the most of context in a mobile app experience with voice. We'll talk about optimizing things around performance a little bit, and then we'll touch on accessibility as well. So starting off with modalities, in the voice space, we see this a lot, this voice first concept, hashtag voice first. It's sort of been, I would say, a pretty big impactful movement that we've seen in the voice space, especially with the growth of sort of first-party voice assistant platforms like building Alexa skills and Google Actions and Bixby capsules. But this concept of voice first isn't necessarily the most, I guess, appropriate for building the best voice experience in a mobile app. So we've seen these sort of interesting differences in approaches to the voice space in mobile. There's this sort of common use case of like basically chat interface, chat focused, putting a little bit of voice in front of that, but basically taking that voice assistant experience and making it the focus of what you're doing at a given moment. And then there's also some other things that we've seen from sort of the original voice experiences in mobile like Siri, where instead of having this sort of chat type interface where we're adding voice, it's sort of this full screen, you're breaking your context and everything is now focused on that assistant. And what I want to talk about a little bit more is that this isn't how every voice assistant experience on mobile should be. And as a matter of fact, it's usually not optimal as a user experience. And I sort of say this as a voice experience on mobile is not the same as a mobile voice experience. And we want to focus on that mobile voice experience and really optimizing how your users are interacting both with your app itself as well as with voice and assistant technology within it. So in those interfaces where we have things like totally breaking the context, totally breaking the focus of the user, and instead owning the experience as that assistant technology, we're losing out on some amazing things we have in the mobile app space, which is some bomb user interfaces and some really beautiful UX and even some standards that we live with. There's a human interface guideline for Apple. There's expectations around how navigation works within a mobile app. There's certain things that we've sort of developed from the origins of mobile app development to now with how users expect to be able to interact with the physical interface. And I think when we take that away and we separate the voice user experience from the actual UI itself, the graphical user interface, we're missing out on a lot of things that we could take advantage of. And we'll talk a little bit about how to sort of make the most of that as well. So what I commonly see, especially with people getting into voice from mobile or people getting into mobile from voice, is this complete separation of your user experience, basically your graphical user experience within the app, totally separate from your voice user experience. And I think a big reason for this is that, you know, the types of people who are building and designing and implementing these things tend to have a very different skill set. It's very different to build a voice user interface than it is to build a graphical user interface. We start to see that the sort of slight overlap when it comes to things like chat interfaces and apps with voice or that sort of like full voice assistant graphical interface. That's more of like a supplement to the actual voice experience itself. And basically, like, I sort of categorize those two original approaches as the sort of UX, graphical UX first, which is the sort of chat interface, and we're slapping voice on top with, and there's that sort of separate focus on the voice UX. And then the other side is like, we're building this voice user experience and we're sort of putting a little bit of graphics on top. But really what it comes down to in building mobile user experiences is that the whole concept of your user experience needs to encapsulate all of it. Your graphical user interface, your voice user interface, your haptic user interface, your cross sort of session experience as well, as sort of all in one thing. And I sort of call this my chickenpox model for building mobile experiences with voice. So that's sort of the modality thing I wanted to talk about a little bit on sort of the visual side is take advantage of your mobile app and treat voice as a supplement to that experience. The next sort of phase of that is like how to actually merge the two together. And the easiest place to start is what I call client-side side effects. So this is sort of a typical flow of just a basic conversation. A user starts a voice request. That could be with a wake word, it could be with tapping a button, it could be going to a certain page, but either way, I'm going to speak now as the user. It's going to then go through this decision engine and process the request. There may be what I refer to as a back-end side effect. So that could be something like, oh, turn the lights on. Well, behind the scenes, we're going to go make a request on behalf of your account and go hit our own API and actually turn your lights on. And that's all happening behind the scenes. The mobile app doesn't really care. It just facilitated your voice. We then send the response back to the user. They hear it, they see it. And then if it's a sort of multi-turn conversational voice experience, we optionally open the microphone back up again. But what's a sort of interesting next step to bridge this gap and have this user experience be in line with your voice user experience is to take side effects on the client side too. And there's a number of different things you can do. And we've seen some great success with others in sort of certain spaces, in certain industries where there's certain use cases where it makes sense. But I'll talk about two very, very common and easy to start with side effects on the client. Basically, the first one, hello clicker, let's go. And I guess I'll just, there we go. Oh, we skipped it. All right, page navigation. And basically here's what it looks like. Going back to that sample app that I showed a couple screenshots of before, sort of a smart home type of app. If I just say to my app, however I want to invoke the voice, but I say, show me how the bedroom looks. Well, if it's a voice only interface, I'm going to say a summary of what your basically bedroom settings are for your smart home. But what I can do is just simply take them to that page. I don't need to break the visual context. I can bring them all of this wonderful context we have in our existing interface to the bedroom. And they're now on this page, and I'm still able to speak and do all those things in the background too. And now they also know that they can navigate to this page manually if they want to basically continue the conversation from here. The second most common thing is kicking off background tasks and scheduled tasks on iOS and Android. So let's go back to this example. I'm in the bedroom. I say, what else can I help with now at the end of sort of giving them a summary? And the user says, turn the living room temp up in an hour. A very specific request. We can do things like navigate. So now we've done two different side effects. We've navigated and we've kicked off a background task on the app side, a scheduler, if you will, to actually change that setting on the user's behalf in an hour. Just a pretty sort of basic example there of actually making the use of the interface, but adding the sort of experience side of it as well. Okay, moving on just real quick to context. I sort of refer to context as how we actually feed the decision engine of our assistant, of our AI. When we talk about voice first context, it basically looks like this. We have the intent and slots that come out of the NLP and NLU. We have some information about the device that they're on. Are they on a speaker only device? Are they on like a smart screen? And then we also have the conversation history, all the stuff that's happened in their current session. And in some cases, what happened in previous sessions as well. When we add user context in a mobile app, we get to streamline a lot of things that are hard in the voice space. We now know who you are. We don't have to take you through an extra set of steps to figure out that you're Alex talking to this mobile app. We don't have to do this sort of account linking. You're already signed in, just pass the token along with the request. We also have more information about your behaviors as a user in the app itself. So we can pull things like app analytics and user information that way as well. And then you're basically adding this alongside that voice context. So now we're getting a little bit more. We've got some information we can feed to that engine to build the best decisions that we can. And this is basically our user plus voice context. The third step is where you can optimize everything around the actual mobile experience. So we've got that voice and user context, but now we also have all of the sensor information that we have permission to access from the mobile app. Don't lose sight of that. Don't ask the user for a location if you already have permission to use it. Just pull their most recent location. If there's something relevant to the experience based off of gyroscopic information or making use of the camera, do that through the mobile app and feed that context to the assistant. And then there's also things like app state itself. If I just log into an app for the first time and I say, show me the bedroom, that's not as relevant as I have this account and I have these 10 different rooms set up and I often go to the bedroom and I'm already on the bedroom page in the app. Take that app state and feed it to the engine as well. And now we have this basically super mega context object that we can use to feed decisions. And in Voicify, we use this alongside our personalization to basically totally optimize the responses that we get and help you customize from there. So there's a couple of different things you can do now in this mobile voice experience based off all this context. You can short circuit conversations. If you're asking for information about the bedroom and you're already on the bedroom page, I'm going to give you a much more brief explanation because you're already looking at it. You don't have to ask for information that you already have about the user. I don't need to ask for your location if I have it. We can provide better follow-ups and discovery of the voice experience based off what we know about the user. We can track additional information in our analytics and our CRMs and our CDPs, and then really optimize those side effects that we're executing on the client side. Like if I'm already on the bedroom page, don't pop another Android activity or a new sort of view on the iOS stack, on the navigation stack, because I'm already there. Don't navigate me. So when we look at that basic example, just show me what the bedroom looks like. there's actually a lot of information that gets fed into this decision of what to do and what to say back to the user and what to show. So we have information like the user's ID and authentication token. We now know who they are, so we know that we can go look up their available rooms that they've set up in their smart home app. We know that they're currently on the home page, and therefore we have that opportunity to navigate them as a side effect. We know that they're currently away from their home address, for example. We know that if they're at home, we can give a different explanation like, hey, you're sitting in your bedroom right now. Why are you even asking that? Just feel the air, weirdo. And we also can know things like the bedroom is the most commonly asked for room. That's sort of that user behavior side of things. This person is constantly making changes to this room. Let's prioritize it when it comes to the actual NLU and decisions. Okay, moving on here to talk a little bit about performance, because it's a very different set of things we have to worry about than we do in the sort of voice first world when it comes to optimizing on a mobile app. Here's what basically the common steps are in terms of just like a single turn in a conversation on mobile, right? So we detect the audio has started. Again, that could basically be through a wake word, it can be through an always on listening, or it could be through a button tap. But either way, we have to start listening. We record the audio as long as we have not detected the end of speech, or if we have basically a guaranteed time to stop recording. We then need to take that audio file, right? We've got like a WAV file, an MP3 file, whatever was recorded from the user, and we need to process that with either automatic speech recognition or just some basic speech to text tools. We then need to take that string and all of that context object and everything else and process the conversation, make that decision, what should happen here. And then on the reverse side for the voice output, we need to generate the text to speech audio. So the reverse, we need to take our text that we want to respond with and or SSML and things like that, and actually generate the output speech synthetically. And then we need to actually play that audio content on the client as well. So there's a couple problems with this. One, it gets really slow for users that are on a low connection. If I'm having interruptions at any point there, because there's a number of different jumps and different tools that I might be using, there's a risk that things will go wrong or that it's just going to be slow. And when it comes to voice experiences, people want stuff immediately. It's got to be fast because we want it to feel human. I want to feel like I'm having a conversation with this assistant in my app. I don't want to feel like I'm just saying something and then watching a loader spin, because at that point I would just do it in a different way. And also these tools get really expensive at scale. Paying for automatic speech recognition tools, it can often be expensive. Same with text to speech at scale. And so there's a couple things we can do to basically optimize what we're going to do offline. So we can do things like automatic speech recognition offline, or our speech to text offline. We can grab as much context and information about the user offline as possible to feed ahead of time instead of having to do those lookups later. So instead of having to say, okay, I'm given a user's authentication token, let me go look up their user ID. If we already have that, pass it along ahead of time to skip those jumps. And then in some cases, we can also do text to speech offline. There's a lot of sort of payoffs with these things, but basically then what it looks like for people doing this with Voicify is that we basically break all dependencies on the internet up until we need to process the conversation. And even in some cases, we can do some of that offline as well. And then basically the actual output speech, if you're using offline TTS, can also be generated entirely offline. The other thing that you need to worry about is what to do when there are breaks in that connection, whether you're doing as much of it offline as possible or just none of it, right? You're just paying for a bunch of services, you're making API calls, you're making HTTP requests, whatever you got to do. The first thing to think about when the connection breaks is how do you handle that and educate the user and let them know what's going on. Users hate spinners, but they can understand if their internet connection has broken and they need to basically try it again later. Communicate that as far in advance as possible, meaning that even if your automatic speech recognition is done offline, but you have a dependency sort of upstream to make a request over the internet, don't let them talk if they can't make the request in the end, because otherwise I'm going to go say something like, hey, take me to the bedroom. And it's going to go, all right, I heard you say, take me to the bedroom. I'll try that later, I guess, when I can get back on the internet. So we want to make sure that we're educating users as far in advance as possible in those connection breaks, especially for apps that have some offline capabilities in general, if they're not entirely dependent on API services. And then the other option, usually the sort of best practices to do a little bit of both, is queuing actions to execute. So if you've already taken automatic speech recognition offline and you have your text to speech offline as well, then you can educate the user that the connection's broken, but you can also then queue that action to happen later. If I say, tell me about the bedroom, I'm probably not going to want to do this because I need that information right away. But if I'm a person that's saying like, hey, can you set the temperature to in the living room? Can you turn it up in an hour, right? That previous example we used, we can queue that for later, but tell the user that it's going to happen later. Say, all right, we've got this. We're going to do some offline syncing the next time you get internet, and then we'll do it for you. But you can handle those types of action queuings or conversational queues where appropriate with offline, then reconnect online and do a syncing. Which is a very common practice to do in mobile anyway, where we're doing things like SQLite or document or just even file store offline on the device, and then syncing that to our servers behind the scenes afterwards. Okay, I know I got a couple of minutes left here. I want to just quickly talk about accessibility when it comes to mobile voice experiences. And the main thing I want to talk about is that voice interactions make people's lives easier when they have a hard time with a screen. If you haven't tried using the mobile screen reader, if your app has not already been tested for accessibility, for people that have either vision issues or physical disabilities that make it hard to use their fingers or hands or other means on the screen, voice interactions creates a whole new way for them to interact. But one important thing to note is that voice is not inherently an accessibility solution. There's a whole bunch of other people that are not able to access your voice experience in the same way. People that have issues with vocals, if they're mute, if they're hard of hearing, if they're deaf. The voice experience, especially in the voice first world, it's not really even an option for them. So you need to make sure, even though you're going to be building a voice experience in your app, that you're not entirely dependent on that for everything that you do. And the way to do that is to break that multimodality dependency chain. Essentially, for things like voice input and physical input and screen visuals and voice output, do not require all four of these to be like possible for your complete solution at the same time. You should be able to do something with just physical input and just screen and visuals, no voice at all. And you should be able to do things as well that a user can speak and then hear information back. And sometimes things like screen reader tech and things like that will help them anyway. But that's basically the gist of it is it should work with no voice input. It should work with no audio output. It should work with no physical input in terms of the conversation at least, and it should work with no visual output. Don't depend on all four of these to be available for your voice experience, or you're leaving potentially hundreds of millions of users worldwide anyway, outside of your experience. They're not gonna be able to do it. And the last thing is train your data set, please, for people that aren't perfectly abled. If you're gonna be doing voice, train outside of your sort of happy user base. And yeah, so just to summarize, basically on the modality side, I shouldn't say don't, but like try to make the use of your existing user experience, of your existing UI with context. Take all that information and feed it to your decision engine like Voicify. Take things offline where appropriate. I know there's plenty of people here that actually build tools for offline speech recognition as well. And then make sure that when you're building voice experiences that they're accessible. And we do a lot of this stuff for our customers at Voicify. It's part of our tooling, especially for the decision making to make that easy. If you want to learn more about that, go to voicify.com or hit me up at adunn@voicify.com. And then last thing, we're hiring like crazy. If you are interested in this type of tech, if you want to keep solving problems in this space, come work with us. And you can find all of our different job postings at voicify.com/careers. And that's it.
Alex, good job. I'm gonna hit reclaim host if you don't mind unsharing your screen, and we're gonna get Ogie with Keen Research up in just a second. But I want to ask you, a question that was asked by Danny Young here in the Q&A, and give you 30 to 60 seconds to respond. And I'm gonna do this for the other two presenters too. What can you tell us about the differences between how your Voicify solution works for native apps, iOS and Android versus web apps in either of those two environments?
No, that's a great question. The general difference, I mean, we can do both, right? You can do voice input and voice output in web apps as well. The main difference is just in how you actually implement things like side effects. So like with our SDKs, with Android, you're doing things like spinning up new activities on navigation and kicking off background threads. Unless you're in a web app that's running as like a desktop or mobile app, you're not going to get access to those types of like background task threads or things like that. And the side effects for navigation are a little different. The other thing is that when you're building a voice experience for web, there is always an indicator to the user that the microphone is on and listening. And they may not necessarily be aware of that, even if it's all entirely offline. Whereas in mobile, if you're listening offline for things like wake words or even for your entire sort of voice implementation, you don't necessarily have to like have the giant blasting like, hey, we're recording you to the user. So that it definitely makes a difference in the user experience and the trust they give you or have for you when you're building voice experiences out in web and mobile.
Interesting. Yeah, great job. Very nice job. Thank you for kicking off voice and mobile apps with us.
Great, thank you.
You got it. I'm gonna put you back as attendee. And next up is Ogie with Keen. Oh, and I think I hit the wrong one. Let me see. All right, there's Ogie with Keen Research. Yeah, wish they made this easier. It moved when I try to promote someone to panelists, just moves all over the place. So sorry to whoever I tried to promote. Ogie, how are you? If you can hear me, you're on mute.
Fixing everything, just a second.
You're good.
You should be able to hear me.
Perfect. How are you
You should be
today?
able to see me. I'm doing pretty well. Thank you, Bradley, for having us here.
Yeah. Thanks for being part of Voice of Mobile Apps with us, Ogie. And I just made you host, and so you can share your screen and
Yep.
you got some
about to do
stuff
that.
going on here. It looks good. If you
Cool.
can make it full screen.
Yeah. I will. There we go.
That's still, it's like in slideshow view. If that's as big as you want it to be, that's fine. It would be maybe you can zoom in on it. Or if you want to leave it as
I think this is the height. Yeah, this is the height. So I think let's just go with this.
Cool.
Yeah, thanks again for having us here. My name is Todic. I go by Yogi. I'm the CEO of Keen Research, and I'll talk about on-device speech recognition. And it's kind of interesting. I had no idea what Alex would talk about, but it feels like a nice introduction in a way with some offline and on-device mentions he had to our talk. So, what we do at Keen Research is basically we help our customers voice enable their mobile apps and custom hardware devices with robust, scalable, private and secure, and cost-effective speech recognition solutions tools. And so our solution is basically an SDK, software development kit, that for speech recognition that runs on mobile devices and custom hardware. It runs on iOS, Android, Linux. We have also some Unity tools. And so all the processing is done locally on the device offline. Are you able to see the screen? I just got some weird message here.
Yeah, it looks great.
Okay, sorry. So no need to use a cloud at all with our solution. The API is very simple, high level, but there's still a number of things that can be customized, and so it's pretty flexible as well. So, given the topic of of today's event, why would you want to use voice in mobile apps? Well, it's all the rage, so you should do it, right? So a lot of people are thinking about, hey, everybody's doing voice, I should be doing voice. Obviously, this is not the reason to do it, but then this may prompt you, it's all the rage, everybody's doing it. Is there something I should be doing with voice in mobile apps, right? But,
actually, Ogie, it's not advancing. The slides are not advancing. I think you're on the fourth one and it still shows the first one. So yeah, it's not advancing, I don't think.
Okay. Let me do this. I'm going to stop the share. I'll try it again.
Oh, yeah, perfect. Thank you.
Okay, and hopefully it'll advance now. So again, it's all the rage, but that's not the reason to do it, really. But might prompt you to think about it. So what you can do with voice mobile apps, you can provide quick, easy, and safe access to information. You can provide quick, easy, and safe way to control your mobile application. You can provide a number of immersive experiences, and I'll talk a little bit more about that later. And then also a number of kind of learning, training, and augmentation experiences that are also very interesting as use cases. So, this gives you a little bit to think about, hey, if you're thinking about using voice in mobile apps. Now, let's say you decided I want to use voice, right? So then, and I think Alex talked a little bit about this. Now, should you use on-device solution? Should you use cloud solution? We're obviously focused on on-device, so we're somewhat biased, but I think, on-device has been when we started this about 5 years ago, it was very, very niche. But now I think it's, it's growing. And I think in the future, there's going to be a lot more solutions that are just on device. For a lot of use cases, there's no reason to use the cloud, basically. That's kind of our position. And so why on device? It provides offline availability. You don't need internet, right? And I think one thing that's very kind of useful here is it's not black and white. It's not just, hey, you're in a cave, you're not going to have the internet or your users. It's really, we've seen a lot of scenarios where there may be an internet connectivity, but it's not reliable. So, think about hospital, think about school, you might be able to connect to the Wi-Fi, but if it's not working reliably, guess what? Your service that talks to the cloud is not going to work reliably, and it's not going to work well. The other one is privacy and security. So with on-device, there is no speech data that's sent off of the device. So, there's a lot of regulation around, let's say in kids, dealing with kids and application that are focused on kids. So COPA, Child Online Privacy Protection Act, HIPAA in medical space. Also, a lot of enterprises are concerned about sending data to the third parties. So that's more on the security side. So with on-device, that's not a concern at all. There's no backend and network dependencies. So just the whole architecture is much simpler than when you have cloud solutions. So you don't need to scale it. You don't need to think about the peak usage, etc. If it runs on device, it just runs. The computer is in your user's pocket, basically. It works in real time. There's no latency, no network delays. In some situations, it's easier to customize. This is changing a bit with cloud solutions, but generally with cloud, the whole kind of value proposition is here's a resource that can be shared among many customers. So customization kind of break that to some extent. And then, with on-device, it's cost-effective at scale. And I think, previous presenter already mentioned this. So typically there's no usage fees, and we'll talk a little bit more about how we deal with this. But, if you have a large number of users, cloud solutions are going to be hard to justify. So what I'm going to do now is I'm going to talk about a couple of different verticals where we see kind of traction, where we have customers, and talk about specific use cases. And I'll take you on a tour. So I'll actually talk about specific customers and how they use our SDK. And I think this will kind of help the audience here understand better what can be done and to some extent how. So these are some areas. I'm actually going to talk mainly about the first two. There's lots of interesting things in gaming and AR, VR as well. So I'll start with EdTech, educational technology, and kid tech. So in this vertical, there's lots of interesting cases around oral reading, instruction, and assessment. So helping kids learn how to read. Early childhood learning, kids that don't know how to read or write, they still need to interact with a device. They can tap, they can browse, but if they can say what they want, that's much easier a lot of times. Language learning, both instruction and assessment. Interactive videos, this is more on the entertainment side, but for a lot of these cases, there's a mix of both education and entertainment. That's the trend we're seeing. And then there's some generic use cases like command and control and app navigation and in-app search. Let's say you have a lot of content. And then like a one-off, it's speech impediment therapy. So there's lots of interesting ways to use on-device speech recognition for that as well. So we have some features that are specific for this vertical. We have acoustic models that are optimized for kids' voices. We have some ways to deal with some of these specific tasks like oral reading, and we're actively working on pronunciation scoring. And we have a slew of customers in this space. So this one is exclusive to Bradley's event today. This is just a couple of days ago, Viacom CBS launched a feature in their Noggin app that's powered by our SDK. So this is the first time we're announcing this. So kids can interact with characters in Paw Patrol videos. So it's interactive videos kind of use case. And it creates this immersive experience. It's not just linear experience. Kids are pulled in into the story, and it gives them some control too. So very early on, but super excited about this. And this whole kind of interactive video use case, I think there's lots of interesting opportunities there. The next one is a company called Novel Effect. Some of you might have heard about this company. What they do is augmented audio reality for storytelling. So the use case is parents are reading from usually from a real book, could be an ebook too, and the app tracks where they are in the book, and then it plays corresponding audio effects. So let's say you're reading and it's like, oh, there was a big thunder and then the window shattered. And when you say thunder, you'll hear the thunder actually coming from the phone. When you say the window shattered, you'll hear the glass breaking. So it creates, again, this immersive experience, pulls kids into the story, creates love for reading and storytelling. One cool thing about this app is, I completely agree with Alex's observations about if you're doing stuff with mobile, you have a screen, there's lots of situations where you should leverage the multimodal interface. The cool thing about Novel Effect app is there's no app, there's no device, there's nothing, right? The experience is the device is somewhere next to you. You're not interacting with the device, you're interacting with the book. And the device is just augmenting that experience and providing, again, immersive experience. So that's kind of totally opposite from this kind of multimodal, but there's some interesting use cases like that too. I just want to bring that up. PBS Kids, they're using our SDK in the Cat in the Hat Invents app. Very simple use case, command and control. Kids can control a robot that's moving around the screen. Again, some educational components in this app. And then a slew of companies that are doing reading apps. So a few of them are basically reading apps and language learning. So several are using our SDK to basically help kids learn how to read. So the app can track kids as they're reading aloud. It provides feedback, assesses their reading skills, etc. And then for language learning, it allows them to speak and to practice speaking. And that's a big kind of thing in language learning is, there's lots of ways to learn it, but until you start speaking, there's this kind of mental block, and talking to the device helps a lot. So just in short, why these customers are using our SDK in EdTech and KidTech, it's COPPA compliant by design. Speech data doesn't go off the device. We have, it's customized for kids' voices, and then we have features that are specific for some of the relevant use cases. I'm going to switch gear, and this is actually a one-off. There's a couple of consumer apps we power, and they're super cool, so I want to kind of showcase those as well. So our friends at AudioKit, which is an open source audio framework, they built a digital voice controlled metronome. So it's called Hey Metronome. And for those of you who don't know, metronome is a mechanical or digital device for musicians that provides them with a beat. So it's like tick, 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 tick. And the mechanical one actually kind of moves like this. So there's lots of digital metronomes these days. What these guys built is hands-free voice controlled metronome. So imagine you're playing a violin, you finished one piece, and now you're switching to the next one. Instead of putting the violin down and fiddling with a mechanical device or with your app, you can just say, hey metronome, set the beat to 100 beats per minute, or hey metronome, play next song, assuming you set up some sort of a playlist. So again, great use case, hands-free, voice controlled, always on listening, powered by our SDK. Another cool app is MiraCheck, which is a virtual assistant for sports pilots. So the use case here is you're flying your Cessna, you're about to take off. There's certain things you're supposed to do before the flight, after the flight, some checklists and procedures for safety, for your own safety, but regulatorily also. So instead of walking around with a piece of paper or with a device in your hands, you connect the headset to, you can predefine these checklists ahead of time, and you just walk around and the app guides you. It says, tires, and you go and say check or failed, and then use fuel, check. So it's super easy, smooth experience, and again, hands-free if you need to deal with anything. Great use of the on-device speech recognition. I'm going to switch gears to enterprise apps. We work with a number of apps or a number of companies that use our SDK in these types of solutions. Generally speaking, there's this whole kind of umbrella of use cases that I like to call augmented intelligence. So we're helping our customers that build mobile apps in this space provide augmented intelligence in their products, in their mobile apps. But it boils down to hands-free voice control, whether it's voice picking, checklists, guided workflows, and then again, some generic use cases like command and control, in-app navigation, hands-free data entry, domain-specific virtual assistants, could be dictation and notes as well. Training and simulation is kind of an upcoming area. And then in-app search, and obviously this can run on mobile devices or custom hardware as well. So some examples: Appify is a software as a service platform. They build these virtual guides, smart procedures and protocols, checklists. So you can define all these on the back end, and then they get downloaded onto the mobile device, and your factory workers, hospital workers, whoever they are, they can just walk around and do these things with hands-free, using just their voice. Eostar as a voice picking solution. Again, warehouse employees, they need their hands while they're for their work. So they have a headset device in their pocket or attached to a forklift or something like that. And they just walk around and interact using their voice with the device, and where all the smarts are, what to do next, what they've done, etc. A company called Centis has a custom hardware device that's a touchless time clock. So it allows factory workers to punch in and out without any physical interaction with the device, just by using their voice. And then finally, University of Louisville, just recently, they started working with us, and it's a collaboration with a large medical device company, and they're doing research around the use of voice for the control of specific medical device for physically impaired patients. So again, why our SDK is useful in these scenarios? It's secure, data is not shared with third parties, everything runs locally. It supports always on listening. It's customizable. Let's say you have specific technical, jargon. It can deal with that, and it provides robust performance in noisy environments. How we work with our customers. So this goes back to this kind of cost effectiveness at scale. Typically, it's a yearly licensing fee that's for a specific app or product. When we license our solution, and this covers all the platforms we support. And for custom hardware, it's usually per device fee with some advance. And to conclude, if this is something that's potentially of interest, we offer a free trial SDK, and we provide a couple of proof of concept apps on GitHub for evaluation purposes. You can check our website. Feel free to email with any questions. And then another kind of exclusive for Bradley's event, you can sign up at this link, and if you do this by the end of this week, we'll provide you with a 2-hour free onboarding support for evaluation of our SDK, and we'll post it's probably already posted in the chat, this link, so you can easily follow it. So that's all I had. Happy to answer any questions.
Okay, that was great. And I'm gonna hit reclaim host, and if you can unshare your screen. Yeah, I'm beginning to realize that, just with Alex's presentation and yours, like this is some really, I knew it was going to be great content, but there's some places that this ought to go. And the Paw Patrol use case, congratulations on that. Your presentation was just an absolute blitzkrieg of, places where you've had successful customer relationships, but congratulations on announcing that one. I will ask you, just like I asked Alex, then we'll move on to Ken from Yobe. What differences are there, or what should people be thinking about when they're applying voice to native apps versus web apps built for a mobile browser environment? Where does your mind go when you're asked that question? What's most important?
So most use cases we deal with, first of all, we currently only support native apps. We don't support web. And we might go down that path. There's some kind of potential. There's a couple of reasons we're kind of avoiding that for now. But a lot of times for the experiences we power, there is a lot of reasons that the customers are already building native solution. So to have hooks to other sensors, etc. So it hasn't been, web hasn't been high on our priority list. I feel like for a lot of these custom virtual assistants, custom experiences, it just makes a lot more sense to have a native solution. So, I might not be the right person to ask this question because we're not focused on the website of things. Yeah, it's hard for me to tell. I think, yeah, I think we're focused mainly on native. Yeah.
That's an answer unto itself, right? Like that's useful information by itself. Ogie, look, y'all are doing amazing work. Thanks for being part of Voice of Mobile Apps with us.
Thank you, Bradley.
You got it. So I'm gonna put you back as attendee. And next up is Ken Sutton. And let me see if I can do this correctly. 18 months into the pandemic here. Ken, you are here and you're on mute.
How are you, Bradley?
Doing good, Ken. Good to see you. How are you today?
Doing well. Thanks for having me on.
You got it. I'm going to make you host so you can share your screen.
Over there.
Perfect. That looks great. Ken, thank you for being here and part of Voice of Mobile Apps with us.
And like I said, Bradley, thanks for having me here. So what I'm not going to do is burn through a bunch of slides. I think I'll give a high-level view of what Yobe does. And then we can hopefully open up some conversations, you and I, because I don't want to not leverage your skills as an interviewer to a certain degree. So I guess at a high level, what Yobe's been able to do is use artificial intelligence to handle the front end challenges associated with voice platforms, specifically mobile, in those environments where, from an auditory standpoint, your background noise, just everyday noise environments becomes a hindrance to accurate ASR or wake word type recognition. And so, if you see here, go back here. There we go. So we are an AI-powered software that tracks unique voice biometrics. Our methodology for dealing with focusing on the voice of interest is to track unique biometrics in the auditory signal. We enhance the signal of interest and we improve performance for platforms like ASR and wake words. And we are a real-time technology. We were operating in the less than 50 millisecond type of time frame for some of our signal processing and our front-end cleanup. And we've really focused a lot of our energy around solving the, what we call the dreaded cocktail party problem. So with the two panelists that you had prior, one of the things that is a bottleneck to having effective ASR or effective speech to text is going to be, how do you clean up the voice signal in everyday outdoor environments in a way that doesn't adversely affect your natural language algorithms on the back end, right? So we have basically been able to come up with an interesting way of melding that, AI and signal processing, some biometric tracking to address the cocktail party problem in a unique way that doesn't create artifacts and some of the things that make your natural language algorithms challenged, and coming up with the right answer to the question. Is this signal in, signal out, garbage in, garbage out type of situation, which we've been spending a lot of our time basically focusing on. We're a little different than most because we are an on-edge solution. So we're computationally efficient, computationally light, but we don't do any real modeling or training. This is inferencing AI on the edge. We're taking a snapshot of what's happening in the auditory scene at any given frame, and we're making decisions from a processing standpoint based on understanding what's happening in the environment at that time. So we're a lot more agile in reference to adapting to what's happening in the scene than traditional, I guess, cloud-based modeling that needs things like reference signals and a lot of computational data in which to come up with an accurate model to deal with signal processing. We're doing all of this on the fly, in frame, making decisions based on what we're seeing, and it's more of an inferencing model in that, versus the data-driven or the modeling-driven type of methodologies out there in the marketplace. And so a byproduct of our ability to focus on the biometrics in these noisy environments is really what does it do to your backend natural language algorithms or something like a wake word, right? So here are some graphs and work that we've done. We were fortunate in our earlier years to get some SBIR funding to quantify the benefit of our solution in front of these technologies. And for wake word, we're giving an average of 20 to 24 dB bounce in SNR. So you can go into the negative, as you see here in the graph, negative 20 dB SNR range and still have the accuracy as if you're actually in a positive 5 dB type environment. And for ASR, and this would be ASR agnostic, whether it be your larger platforms like Google, IBM Watson, or even Amazon, or giving roughly a 17 to 18%, depending on the environment, bounce to your ASR. So we can actually create a much more conducive environment for these solutions to work properly. And I guess we would sit in the traditional AFE bucket with other AFEs as far as an audio front end. And because we're not creating a lot of diverse artifacts to the signal, we partner very well with keyword commands, voice biometric solutions, and metadata extraction solutions. We do see a future for us where we're going to, move our technology into different areas where we're going to be, doing a lot of our own in-house adaptive recognition, biometric identification, and metadata extraction to try to create a more human type of interface where we can actually pass along context to the voice signal on the edge for our larger partners and cloud-based partners to actually use that data to get better and more personalized interaction with the user. And for us, we're focused primarily on the app development community because we are software based and we are platform agnostic and we're form factor agnostic. We do have one criteria, we're based on human hearing. So we do like to have 2 signals or 2 microphones. And all of you smart speakers are now having 2 or 3 or 4 microphones, depending on the brand. We can be form factor agnostic. We sit in this SDK stack with our partner and we handle all the audio front end manipulation that they need to basically create an accurate voice signal for them to basically then process. So at a high level, I'll stop there, Bradley. I don't know if there's any questions. But the 2 panels that you had, we are, it seemed like you picked your panelists, very strategically. We would fit at the front end of those solutions and really help manage some of the acoustic challenges associated with being in different environments, specifically in mobile brands, where you can't control the auditory environment from a cell phone because the environment changes so dynamically depending on where your user is going to be at that time in that place.
No, that's cool. And you've got I'm gonna hit reclaim host. And if you want to unshare your screen, I've got definitely my share questions for you. And you've got a number of slides that we'll make sure that everybody who's registered will get this content, but we're going to figure out some other things to distribute this too, because there's some really interesting things that just as you sort of scroll back through it here. But if you unshare it and we can just talk for a second, because before the pandemic, there was a whole different way of looking at things like voice biometrics. There was a whole, I could go up and down the voice and AI value chain and talk about all sorts of things, synthetic voices. I could talk about biometrics. I could talk about anything, big tech solutions. And there was a totally different set of opinions and things you would hear parroted than what you hear now. This next chapter we're all about to enter, the ubiquity of voice and how it's grown over the pandemic. Is there anything that doesn't need voice biometrics? Is this really the time? Like, what's your your adoption looking like? I mean, is this go time?
Yeah, it's interesting, and I want to be careful how we talk about biometrics, right? There's the authentication lens of looking at biometrics, and then there's the identification lens, right? And so we tend to spend more of our time on the identification part. We're not trying to create some type of a real arduous voice print that we have to worry about the security. All of this is done on the edge anyway, so that's where our security protocol is. But what we really want to do is make it so it's a seamless interface, right? So we just want to know it's Bradley talking, right? We're not trying to figure out, is it really Bradley, because we want Bradley to move money from his Barclays account to his Bank of America account. So in those areas where you can take a voice print with a certain amount of numbers and data that can sit on the phone, no different than your fingerprint access to get into your mobile phone, We use it to track voice without any precursor. We don't know it's Bradley's voice unless you give us an imprint and we know it's Bradley's voice. What we do is we know there's 3 or 4 voices talking in the scene at one time. So we can toggle between those voices and we can pick what output we want. So if we want speaker 1, speaker 2, speaker 3, speaker 4, we can diarize and we can figure out which ones we want to focus to. But we don't have any knowledge of who that person is unless it's, let's say, Bradley's phone. And you give us an enrollment and you say, I don't want this phone to respond to anyone but me. So therefore, we use it as a biometric link to say, okay, this is our user profile. Our user profile is this biometric. We know it's Bradley's unique phone number. We have all of the metadata associated you have with someone owning a device already. We're just using the voice as our trigger to basically we pull up Bradley's profile if it's some streaming media platform, we want to know what your playlist is and things of that nature. And that's kind of how we look at biometrics. The authentication stuff, we've been very diligent to not get into that space. And we do a lot of work with 3-letter agencies in DC. So this is something that we get pressured to go into a lot. We're waiting for the market to catch up to figure out what that's going to look like on the consumer side. But we're just using biometrics as our methodology of tracking what are we paying attention to. And then we lock on that and we basically strip out everything that we don't need that's not a voice of interest.
You talked about the cocktail party problem, and that's an easy thing to envision, and that's clearly something that has to be solved. However, it's easy to sort of assume that maybe that's the most important problem. Is it? I don't know. Do you think that's the most important problem to solve? What are some other problems that might be equally as important that maybe you didn't cover there? Because that one's important, but what are some other ones?
Well, I mean, I think to your point, it's a major problem because so many other things in the value chain are influenced by it, right? So if we're talking about the cost of using back in ASR in your API calls, the larger incumbents that you're using for your backend ASR, they don't sit and go through any type of accounting on if the command was recognized or not. You're getting charged for the API call, whether it was clean or it was dirty, right? So there is a cost saving associated with solving the cocktail party problem. But to your point, I think that what we found, it's not just the SNR signal noise to get a clean speech. There's also a lot of metadata in voice that we're spending our time on, right? So we are talking about, can we pull things like intent and high level emotion detection out of a voice signal? We're doing things with partners where we're giving direction of arrival, which is very important for, let's say, an appliance company that wants to have their air conditioner, have the vents pointing towards you when you're giving a voice command, so it needs to know where you're located. And so if you think about the cocktail party problem, what are we doing as humans from an auditory standpoint that we're using AI as Yobe to basically duplicate? It's all the metadata in voice. So if you take the cocktail party scenario, right, and you add another element where someone walks into the cocktail party and they scream the word fire. So as a human, we've figured out where that person is geolocated to us. We know they're to our back left corner. We don't have to turn our heads. We know they're there. We know if it's a man or a woman. We know if it's a child or an adult. But more importantly, we know if they were serious or it was a joke, right? All of that metadata, all that intent is trapped in the voice signal. Our thesis is, and we're seeing this play out with some of our engagements, is that as these conversational AI platforms and other backend platforms become more robust, having that metadata come in and using it to basically personalize the experience is very important. So I think it's the cocktail party is the signal to noise issue, but it's also, can you get the intent and can you get some of the other more humanistic values that are trapped in the voice out of it and extract it so customers and platforms can use it to have more human-like engagement.
So I want to close, and this is just a convenient way to close the whole thing. I want to ask you sort of a broad question. When you look at the 3 companies, you sort of noted, there are some commonalities between the 3 companies that are part of this event today. And the biggest one is they're all independent players. If you had gone back, 3-4 years ago, there was a prevailing thought, and it was what stifled in a lot of investment in the space and why it's been activated like a fire hose, is that big tech is going to swallow everything. Amazon sees what you're doing, Ken. They're going to say, come here and give me that. Google sees what Ogie's doing, Keen Research. They're like, we'll just copy that. And so it had a chilling effect on, people coming into the space to some degree, but really it had a chilling effect on dollars. Now we've seen almost a total reversal where there's a realization of a different prevailing thought that there are harsh limitations to what big tech is going to be able to do in this space without getting violent, metaphorically violent pushback from different areas. And so my question for you is, you're growing a company in the space, you're really on the bleeding edge. How do you view Amazon, Google? Do you view big tech as a threat to your solutions with Yobe? And all three companies on here play nicely with big tech, but they've carved out their own space. Walk me through your mindset with regards to that.
Yeah, and it's a loaded question, Bradley. To say in an open mic. So I'll say it this way. We have been very deliberate to make sure that we've partnered and become an enabler for all platforms that want to use a clean voice signal, right? And so where we've basically been able to etch out our little patch of land is that we've been, focused on the on-edge, on-device, front-end way of looking at the challenge. So we do have some insulation because our science is novel. That I'll admit to the fact that the way that we're doing what we're doing is not something that's, we're not just taking a beamforming methodology and packaging up in a new way of doing these type of things. It is a totally different way of looking at isolating the signal of interest. But I think that because, to your point, the market is fractioned to a certain degree. And this push to really getting these platforms more and more robust is driving the kumbaya feeling we're having in voice right now, right? We just don't have time to start developing solutions that we don't have core competencies for because the market is moving so quickly. So it's easier to engage with companies like you have on the panel who are proficient at what they do and experts at what they do than try to erode that market that they're trying to get into. We just don't have the time. And we see it happening with the incumbents in ASR, who are giving a lot of areas of, especially, when you go overseas and you look at companies that are looking at ASR in these areas where the dialects are very regional focused. Google's not trying to go and figure out, listen, I have the best Indian language platform for all the dialects in India, right? They're working their models based on their sweet spot, and it gives room for some of the smaller organizations to come up and basically offer some services because the market is moving so quickly that right now, no one's paying attention, if you would, because it takes too many cycles off to try to focus on areas where you have unique technologies. And that's what we're seeing in our engagements.
Well said. Great way to close. Ken, thank you for being part of Voice of Mobile Apps with us.
Bradley, thanks for having me.
You got it. So I'm going to put you back as attendee. Very different sort of event here. Thank you for being part of it with us. We're going to make sure that all participants, all registrants receive audio and video after this concludes, and we'll make it available in some other ways too. We'll share that online just to get it out there. These are three great companies. Next up for us will be Project Voice X. We'll be in person in Florida, and we'll be sending information out about that as well. Thank you for being here today. I'm Bradley with Project Voice. Until next time.